Hello, and welcome to my introductory presentation on the heat treatment of steel for knife making applications. Firstly, what is heat treatment? Simply put, heat treatment is any thermal process performed on a piece of steel to change its properties to suit the knife maker's current needs. There are a few terms which will be necessary to define before we continue, but firstly I pose the following question. Why is heat treatment necessary? At various times during the construction of a knife, the properties of its steel blade, in terms of hardness versus softness or toughness versus brittleness, must be altered for practical purposes. Carbon alloyed steel, that is iron with the appropriate amount of carbon added, has a unique feature which allows it, given the appropriate heat treatment, to harden to the point where it will break like glass if tapped against a hard object. Conversely, by utilizing another heat treatment process, the same blade can be softened to the point where it can be bent, hammered, ground, or worked into shape. That both these states can be achieved within the same blade, thus maximizing the hardness of its edge for edge retention and maximizing the toughness of its spine by creating a lesser degree of hardness there locally, is a fact used by the knife maker to achieve the maximum utility in any blade. So let's get back to these definitions. Firstly, for the purposes of shaping the blade to its desired profile, two typical methods are employed. One is forging and one is grinding. Forging represents the first term, which begs definition. Forging is the use of high heats to bring a piece of steel to a plastic state where it can be hammered into shape by the knife maker. This process puts tremendous stress on the blade, which needs to be alleviated by a further heat treatment process known as normalizing. Normalizing, as its name indicates, is a heat treatment process which renders the steel from its altered state due to prior processes, such as in its stress-increased state due to forging, to a state which permits further treatments of the steel without jeopardizing its integrity. While normalizing typically renders the steel ready for further heat treatment processes, grinding operations are best done while the steel is in its softest state, which requires annealing. Annealing is a heat treatment process which returns the steel to its absolute softest state for working. Not all steel is purchased in its annealed state, so sometimes this process must be done first prior to cutting and grinding operations. Hardening is the heat treatment operation which, as its name suggests, changes the atomic structure of the steel to impart the quality of hardness, which is required of a blade's edge so that it may cut appropriately without dulling too quickly. Quenching is the term which applies to the rapid and forced cooling of a blade from its unique hardening temperature to a much lower temperature. The result of the quenching process from the correct hardening temperature results in the attainment of hardness, as mentioned a moment ago. Tempering is the heat treatment operation which is used to reduce the fully hardened state of the blade steel, which is generally too hard and brittle for normal knife use, rendering it hard but with its brittleness reduced to within acceptable parameters. There are several methods of heat treatment for knife steels which result in the required combination of hardness at the edge and toughness at the spine, the combination of which results in the ultimate attainable utility in knife making. A simple and very effective method is known as edge quenching, whereby rather than rapidly quench the entire blade, only the edge is placed into the quenchant, be it oil or brine, which rapidly cools the edge, resulting in maximum hardness there locally, but the less rapid quench of the air-cooled spine results in a lesser degree of hardness there, thus imparting the desired toughness. Another method commonly used by custom knife makers is known as the soft back draw, whereby the completely quenched and hardened blade is subjected to a reheating process of its spine only, typically using a torch, which tempers the spine locally, resulting in the desired dual hardness. The third, time-honored method most associated with the creation of the Japanese sword is known as clay firing, a method which employs the use of an insulative clay applied to the spine of a knife prior to hardening, which, when fully quenched, insulates the spine against the rapidity of the quench, thus resulting in the desired dual hardness. This technique will comprise the subject matter of my next instructional video. These methods, initially used for practical purposes only, also have their place in defining the overall aesthetic of the finished knife, in that the dual hardness can be seen to exist by virtue of either the torch colors remaining after the soft back draw, as can be seen here, and the wonderful temper lines which result from the clay-fired technique, which can be seen here. Well, there's voluminous knowledge required for the effective heat treatment of knife steels, but I hope these basics have served as informative and intriguing. Thank you for watching.